Hello and welcome to Math Tape 053, Subtracting Rational Numbers. We have only one objective on this tape, and that is to learn to subtract rational numbers. So let's begin right away. We'll start with a very simple example. 9 subtract 4 is equal to 5. You already know how to add rational numbers. Compare the problem 9 add negative 4, which also is equal to 5. It doesn't take very much effort to discover that subtracting a number is the same as adding its opposite. And so that's exactly what we do to make the rule for subtraction. Here is an extremely important rule. Be sure you write this very carefully in your notes. Make sure it's exactly right. The rule is to subtract two numbers, leave the first number unchanged, and add the opposite of the second number. To subtract two numbers, leave the first number unchanged, and add the opposite of the second number. To subtract two numbers, leave the first number unchanged, and add the opposite of the second number. Let's look at some examples of this rule at work. First, let's do 12 subtract negative 3. Our rule says leave the first number unchanged, and so we write 12, and add the opposite of the second number. To subtract negative 3, we will add the opposite of negative 3. The opposite of negative 3 is 3. So to subtract negative 3, we add positive 3. And then the problem becomes a very easy addition problem, 12 plus 3, which is 15. And that's the correct answer. So 12 subtract negative 3 becomes 12 add positive 3, which is 15. Next, let's do 8 subtract 11. The rule says leave the first number unchanged and then add the opposite of the second number. 8 subtract 11 says to subtract 11, we'll then add its opposite. Opposite of 11 is negative 11. So we have 8 add negative 11. This is also a very easy addition problem. 8 add negative 11. Remember that the rule says that when you're adding numbers that have opposite signs, you take the difference of their absolute values and use the sign of the one that is greater than absolute value. And so we get negative 3. Negative 6 subtract negative 1. The first number is unchanged. To subtract negative 1, we'll change to add the opposite of negative 1, which is positive 1. And so we'll get negative 6, add positive 1. Negative 6 add positive 1. We're adding two numbers with different signs, so we take the difference of their absolute values and use the sign of the one with the greater absolute value. And so we get negative 5. Negative 9 subtract 6. Leave the first number unchanged. To subtract 6, we add the opposite of 6. The opposite of 6 is negative 6. And so we take negative 9, add negative 6 to get negative 15. Remember, the rule for adding numbers with the same sign is we add their absolute values and keep the same sign. Let's notice that in doing subtraction, we're forced to make a double change for each subtraction. Do not change the first number. The first number is left unchanged. We change subtract to add, so that's a change. Subtract to add. and we change to the opposite of the second number. The double change, if you make only one change, the problem will not be correct. If you make more than two changes, the problem will not be correct. You must make the double change subtract to add, and change to the opposite of the second number. Let's look at some more examples. First, 7/8 subtract 2 3/8. In order to subtract these numbers, we must get the same form. We have a fraction and a mixed number. We'll change the mixed number to an improper fraction. Recall that to change a mixed number to an improper fraction, we multiply denominator times the whole number portion, add the numerator, and that gives us the new numerator to be put over the same denominator. 8 times 2 is 16, plus 3 is 19, and so 2 3/8 changes to 19/8. So that gives us 7/8 subtract 19/8. Then, to subtract a number, we add its opposite. We change subtract to add, and we change to the opposite of the second number. And so this becomes 7/8 add the opposite of 19/8, which is negative 19/8. 7/8 add negative 19/8. Then to add these fractions, they have the same denominator, and so we simply add their numerators. 7 plus negative 19 gives us negative 12. So we have negative 12/8. But that fraction can be reduced. We never leave an unreduced fraction when it can be reduced. Each of these numbers can be divided by 4, giving us negative 3/2. Some people, by the way, prefer to have an improper fraction converted to a mixed number. If you fall into that category, it's perfectly correct to change this negative 3/2 into negative 1 1/2. That answer is equally correct, and you may do either that you prefer. I prefer to leave the improper fraction form for two reasons. One is there's less work. The other is this number is ready to be used in, for instance, a multiplication or division problem, whereas the mixed number would have to be converted back to the improper fraction form to be usable in that regard. But take your pick, either of these answers is correct. Let's work with some decimals, rational numbers written in decimal form. Our next example has negative 3/10 subtract negative 1 62/100. To subtract a number, we change to add its opposite, and so this becomes negative 3/10 add positive 1 62/100. Remember that to add decimals, we line up the decimal points, and doing so we will get 1 32/100. A combination of several terms, negative 9, subtract 23, subtract negative 4, subtract 6. To subtract a number, we add its opposite. Negative 9 is unchanged. Subtract 23 becomes add negative 23. Subtract negative 4 becomes add positive 4. Subtract 6 becomes add negative 6. And then, simply adding from left to right, we add negative 9 and negative 23 to get negative 32. Copy the 4, copy the negative 6. Notice I have stopped writing the plus on the 4 because it's unnecessary. Add negative 32 and 4, and we get negative 28. So we have negative 28, add negative 6, and adding these two numbers gives us negative 34.